Hi guys, let's see today's question. So today's question is based on the idea of definite integrals where we have to solve the integration questions with limits provided. So the limits given to us in the question are pi by 12 to pi by 4, and the question or the expression which is given to us that we need to solve is 8 cos 2x, and the denominator is tan x plus cot x, right? So first of all, let's evaluate this denominator separately. Whatever we get as a denominator, we will directly substitute it in this expression. So if I first solve this part only, tan x plus cot x, I can write tan x as sin x by cos x, and I can also write cot x as cos x by sin x. So here, if I have this with me, I can write it as sin square x plus cos square x upon cos x into sin x. So now if I further solve this, if you know the identity, it says sin square theta plus cos square theta is 1. So sin square theta plus cos square theta is 1. So this part becomes 1. So I get 1 upon sin x into cos x. Now, if you know the angle, double angle formula here, it says sin 2 theta is 2 sin theta into cos theta. So if I use that idea here as well, I need to multiply both sides by 2 so that I can use that idea. So I'll multiply here by 2 as well as here by 2. That gives me it is 2 upon 2 sin theta cos theta. Now I can write it as sin 2 theta, so sin 2x. So this is how we reduced our denominator. Now if we put whatever the expression we have got in the denominator in the original question here, so the question now turns to pi by 12, pi by 4, 8 cos 2x. Denominator is given to us, it is now 2 upon sin 2x. So 2 upon sin 2x, that is having the whole cube dx. Further, if I want to solve this, becomes pi by 12 to pi by 4, 8 cos 2x upon, now 2 cube is 8, and the denominator has a denominator which becomes sine cube of 2x, which actually comes in the numerator, right? So this becomes sine cube 2x dx. Now, if I again see, I can directly cancel 8 throughout. Now, if I again want to use that formula of double angle, I can use it. So now I'll use this idea that sine 4 theta becomes 2 sine 2 theta into cos 2 theta, right? So again, I need to adjust the 2 here. So I'll multiply both sides by 2. So if I multiply numerator by 2, I'll have to multiply the denominator. So pi by 12, pi by 4, and this becomes, so if I use this idea now, it says 2 cos 2 theta and sine 2 theta. So there are 3 sine 2x. I'll use only one sine 2x. So I will get sine 4x with that. But apart from that, there are 2 sine 2x already remaining. So it's sine square 2x yet and 2. Right? Let's move ahead now. So if you know this formula for double angle, that said 1 minus cos 2 theta is 2 sine square theta, right? So if I want to write the previous expression, I had sine square 2x. I'll write that first. Limits were from pi by 12 to pi by 4, and the question had sine 4x, sine square 2x, and the denominator had a 2. Right? Now, I can write this sine square theta as 1 minus cos 2 theta upon 2. Simultaneously, if I want to write sine square 2x, I'll have to write 1 minus cos of 2 into that angle, that is 2x, right? So the limits goes from pi by 12 to pi by 4. This becomes sine 4x. This becomes 1 minus cos 4x upon 2, and a 2 from here also, so that's 2 again. So that gives me 1 by 4 pi by 12 to pi by 4 sine 4x minus sine 4x into cos 4x dx. So again, if you use the double angle formula that said sine 2 theta is 2 sine theta cos theta, so I'll again multiply this part of the integral with 2. So multiply both sides by 2. So now the question turns out 1 by 4. I'll take both of these expressions separately now, because pi by 12 to pi by 4 sine 4x dx minus 1 by 4 into 1 by 2 integral pi by 12 to pi by 4, and 2 sine 4x and cos 4x turns out sine 8x dx. Right? Now, if I want to further solve this expression, I know now that 1 by 4, if you know the integration of sine 4x dx, it is integration of sine theta is minus cos theta. So minus cos 4x, and whatever is the coefficient of x, we have to divide by that. So it becomes dividing by 4. Limit goes from pi by 12 to pi by 4. Further, it was minus 1 by 8. So minus 1 by 8. Now, sine 8x, I can again write sine theta, the integration of that is minus cos theta. So minus cos 8x dividing it by 8 again. And again limits goes from pi by 12 to pi by. Further, if you solve this, 1 by 4 and a 1 by 4 yet common from this also. So it gives you minus cos, limit is pi by 4. If I put that, becomes minus cos pi, plus, because minus of minus, that is plus now. Now if I put this, it becomes pi by 12. So it becomes cos of 4 pi by 12, that is cos pi by 3, that is cos 60, minus 1 by 8 into 1 by 8. Again, this, if I put pi by 4 here, becomes minus cos of 2 pi minus minus plus, so cos of 8 pi by 3, that is cos of 2 pi. Now if we talk about cos of all the angles, we know cos of 0 degrees is 1, cos of pi becomes minus 1, cos of 2 pi becomes plus 1, and if you see at the middle angles, that is cos of pi by 2, it becomes 0. Cos of 3 pi by 2, it again becomes 0. Right? So if I draw this graph first, so you understand this 1, 0 and minus 1. So your graph looks something like this. So at 180 degrees, it becomes 0. At, sorry, 180 degrees, it becomes minus 1. At 90 degrees, it becomes 0. And further, it goes from minus 1 to. So this is the entire function of cos for the angles from 0 to 2 pi. So now if I use that idea here, 1 by 16 minus of cos pi is minus 1 already, so minus of minus 1 becomes plus 1, and cos of pi by 3, that is cos 60 is half, minus 1 by 64. Now minus of cos 2 pi, so cos 2 pi is already 1, so it becomes minus 1, plus cos of 2 pi by 3. So cos of 2 pi by 3, 2 pi by 3, if you find out, it is basically 120 degrees, and cos of 120, if you see, so it is on the negative side, and cos of 120 is nothing but minus half. So here if I solve this further, it gives me 1 by 16, 3 by 2, minus 1 by 64, minus 3 by 2. So if I solve this further, it gives me 1 by 16, 3 by 2, and minus and minus becomes plus, so it becomes 1 by 64, 3 by 2. So I can see 3 by 2 is common, 1 by 16 is also common. So what I'm left with is, in the first part nothing is left, so 1. In the second part, 1, and the denominator we have taken out 16 common from 64, so we are left with 4 here. So 3 by 2, 1 by 16, and this becomes 5 by 4. So further, if I solve this, it gives me 15, and 64 into 2 is 128. So the correct answer for this question, which was given to us, is 15 upon 128, and that is our option A. So correct answer for this question is option A. I hope you understood how to solve the questions on definite intervals as well. We'll meet again tomorrow with the next question. Till then, like, share, and subscribe if you found this really helpful. Thank you.